Okay, I'd like to build this circuit right here that has a capacitor, a resistor, and it has a power supply that we can turn on and off. But instead of using a power supply with an on-off switch, we're going to use a square wave so that we can rapidly supply power and then turn it off for this circuit. So I have a 0.01 microfarad capacitor here and a 10 kilo ohm resistor here. Now the output that I'm going to supply here is coming from this function generator. I have it set on a square wave for about 1 kilohertz, and I believe it's at 5 volts peak on the output. So I'm going to take the output cable here and I'm going to hook it up so that the the negative here goes to the capacitor. So there's the black lead over like that. And then the positive is going to go over to the resistor. So the switch and power supply combination here, the switch and DC power supply combination, is going to be replaced with a square wave output. So the next thing I want to do is monitor the output of this circuit. So I'm going to look at channel 1 of the oscilloscope right here. That's the yellow channel right here. And I'm going to take that and I'm going to measure across the entire circuit. That means I need to have the black leads in common right here and the red leads in common over here. So now I'm basically just monitoring the input waveform to my circuit. And you can see on the screen here, I can adjust the time per division settings so that I can see I have a square wave input into the circuit, and you can see that I have dialed in here, because it's 2 volts per division, I have 5 volts up and 5 volts down. So that's a 5 volt peak square wave being fed into the circuit. What I'm interested in is looking at the output from just across the capacitor so that we can see it charging and discharging. To do that, I'm going to put the channel 2 cable only across the capacitor. When you're building circuits like this, it's very important that you have a common ground. That means that all of these black leads have to be in common. But instead of across the entire circuit, I'm only going to measure across the capacitor so that I can see the voltage versus time just across this. In doing so, I look on the oscilloscope screen here and I see the blue trace corresponds to channel 2. So I could turn off the channel 1 by holding that down, I believe. See if we can get that to turn off. There we go. And what we see here is that as the input signal is going from 0, well, actually from -5 to plus 5, we're seeing that the capacitor is getting charged here and then discharging here. So that's an exponential kind of behavior. You can put the input waveform in there again, and we see the charging of the capacitor here and the discharging of the capacitor here.